Okay, so students, we start the next chapter, register transfer and micro operations. So in this chapter, so we discuss about how the registers are interconnected in the digital system and how they are transferring information from the one register to another register. So here, if we go for the digital system, so what is the digital system? Okay, suppose if I go for the any software, okay, suppose there is a software called as the MS Word, suppose we are taking. So in this MS Word, we have the different menus, file, edit, view, so everything. Under the file menu, again we have the, so new, open, save as, so like this. So please, what is this software? This software contains different operations. Okay, if you go for the new, so what is the new contains? What is the new? So what is the new means? It is a program. Simply it is a program. It has some set of instructions. Okay, it has some set of instructions. It performs a task. What is the task? It opens a new blank document. So means if you are discussing about the software, a software is a collection of programs. A collection of programs. So see here in the come to the digital system, so it is also interconnected with the hardware components. It is interconnected with the hardware components. So how the software is a set of programs, so like that digital system is a set of hardware components. So what are these hardware components? Okay, every component is executing or performing some task. Okay, so that is called as the module. Okay, but here these are called as the hardware modules. Okay, so these are called as hardware module. And come to the here, so what is this one? It is called as a procedure. It is called as there is some synonyms for the functions. Okay, function means a set of programs, a set of instructions. Okay, it performs some specific task. The synonyms for the function is procedure, subroutine, okay, procedure, subroutine, function, module. So all these are the synonyms for the function. Okay, so whatever the word, so what is the meaning of those words? A set of instructions. Okay, a set of instructions performing some specific task. Similarly, here the digital system is a set of hardware components. Each component is performing a specific task. Okay, so here how it performs? So that is called the module. It will also have some specific set of instructions. Okay, to perform a specific task. And here in this digital system, that is called as module. Okay. So now we will see. So what are the operations? So from every module contains a set of instructions. Okay. So here every function procedure or contains a set of instructions. So similarly, what is the digital module? Okay. So what the digital module contains? Okay. So what the digital module contains? Okay. So what the digital module contains? It contains data. It contains the data and as well as it contains some hardware components. Okay, and here to store this data, so we have the registers. Okay, the hardware components contains data and to store the data they contain the registers. Okay, so now what is the data list? Normal data and as well as instructions. So now we will see. So what to understand? So there is a data, okay? So the data is stored in the registers, okay? And it is also processed within the registers. So now we are going to discuss about how the registers are, okay? Suppose this is some register R1 and this is the R2. So how they are transferring data in between them, okay? That is the register transfer. And the second one is the micro operation. So what is this micro operation? So here, this diagram, the operations executed on data stored in registers. The operations, okay. So here, what is this one? The operations, okay. The operations executed on data, okay. So the operations executed on data. What is the specialty of data? Which stored in registers. In the previous class, we discussed about the data is stored in memory and as well as in the registers. Okay, so here we have to say that the operations executed on data which are stored in the registers. Okay, so such operations are called as micro operations. Okay, so they are called as the micro operations. Now, if you go for the any internal hardware organization, okay, suppose we are always we are executing some C programs or C++ programs. To execute a C++ program, what you require? You require a editor. Okay, you require an editor. Why you require an editor? You are typing your program, your code, C++ code, everything. After that, so you are executing that code. So for the execution, so we require some supported files. Okay, so they suppose if our C++ stored in the some variable, okay, so some folder, Surya folder. Now, if you go to that folder where your C++ software is located, there you can find .obj plus, obj programs, .cpp, okay, .dll. You can find all these, okay, .exe files. Why this? So all these files are used for supporting your C++ program to perform a task. So similarly, here in the digital components, okay, the hardware organization here, the internal hardware organization of digital computer. Okay, compared to the software simply. So here the software requires different programs, okay, different categories of files to execute this program. Similarly, the internal hardware organization of digital computer. Okay, if you open a digital computer, so there we can see different devices, components. So how they are organized, okay, how they are combined, how they are communicate with each other. Okay, so for that what the digital computer requires. Okay, so what it requires? So first of all, it requires the set of registers. Okay, what it contains first of all, set of registers. It contains set of registers because in the registers only the data can be stored. Okay, and the second one, the sequence of micro operations. What it is a content required here? The sequence of micro. This is the micro symbol. Okay, the sequence of micro operations. Okay, already many times I told you. C equal to A plus B is the instruction. Okay, in this instruction, so we are again performing some sub operations. Read the value of A, read the value of B. Okay, so add A and B. Next one, so store result, okay, into C, okay, print the value of C, okay. So like this we have discussed in instruction a set of operations. So now to perform a task, we require registers and we require some sequence of micro operations. Here sequence means that, so they are executed one by one, okay, without any interruption, okay, they are executed one by one. And lastly we require the control. We require some control to control the flow of the instructions. Okay, so we require these three for the digital computers. Okay. Okay. So next technology important in this register transfer long list. Okay, RTL. So how we have the C long ways, C++ long ways like that. For the digital computers, we have a long ways called as RTL, register transfer long ways. Okay. So what is this register long ways? The symbolic notation used to describe the micro operation transfers among registers is called the register transfer long ways. Okay, so here we take the symbolic notation. Okay, so we are representing the micro operations performed within the registers. Okay, is represented as with some symbolic notation. Okay, if you see the C, C++, then we have the English-like words. We have instructions. Okay, English-like words. So similarly, this RTL. In this RTL, the operations are described as with some symbolic notation. Okay, we will see what are these. Okay, so now what is the register transfer? First we will see up to this point. Next we will go for the long ways. Okay, register transfer. Okay, so for this register transfer, in the computer registers we have different registers. Okay, for the different purposes. Suppose if you have a register called as DR, data register. It is stores only data only. Similarly, suppose we have some register called as IR, instruction register. It stores only instructions. So like that we have the different registers. Now in this RTL long ways, the registers are represented by capital letters. Okay, the registers are represented by capital letters. Suppose register R, okay, register A or register R2. So like that. Okay, next one. And also in the symbolic notation, how it is represented. In the symbolic notation, how it is represented. So simply we are writing R1. In a rectangular box, we represent the register. Okay, so it is the R. Suppose if you are writing 0 and here we have 7. So means this is the register A with 8 bits. Okay, so register A with 8 bits. And similarly, we have, and sometimes the register symbols are represented like this. Okay, so these individual bits in the register, okay, it represents individual bits. And sometimes we can represent in register, so like this. So one is the, suppose this register name is PC. Okay, so now we can write PC of H and PC of L. Lower order bits. Okay, and suppose if it is 0 to 16, so means that it is a 0 to 15 means it is a 16-bit register. Okay, so lower order means 0 to 7 bits. Higher order means 8 to 15 bits. Okay, a register can also be represented like this. Okay, and also we can represent the register values. Okay, suppose this register name is a PC. Okay, so PC of 0 to 5. PC of 0 to 5. So means that, so here we have the PC register. In this PC register we are taking only some part of bits. So that is 0 to 5. We are taking only 6 bits. Okay, among these 16 bits. Okay, we can represent like that. Okay, so this is the symbolic notation for the representing registers. Okay, so next we will see register transfer. Okay, next we will see the register transfer. Okay, now here, okay, it looks like this. Suppose if I say like this, in our C or C++, if you write like this, how we can read it? A equal to B is, the value B is transferred to A. Right? Suppose A equal to 10. So means the value 10 is transferred to A. So similarly, the content of the data in the B is transferred to the A. So similar manner here also we have R1. The contents of R1 are transferred to the R2. Okay. Here we are using the word transfer. Here we are using the word assignment. Okay. So the content of the R1, register R1, are transferred to R2. Okay. So here we can write the same representation like this. If B equal to 1 colon R2 represents R1. Okay. So previously there is no condition. Okay. Suppose in the C program or C++, we have conditional operations. Okay. Unconditional operations. Go to is the unconditional operation. Go to statement is the unconditional operation. So means, okay, without any checking the condition, directly the control is moved to the particular statement. Okay, so here it is the unconditional. Okay, suppose if you are taking, if P equal to 1, okay, R equal to R1. So means, okay, then if P equal to 1, okay, so then it will also be. If B equal to 1, then R2 plus R1. Okay, we can write the statement. Suppose we can write it. Okay, then R2 implies R1, not implies R1 transfers R1. Okay, we can write it like this. P implies, okay, P means R2 implies R1. Okay, it's simple language, so we are writing like this. So this is the RTL language. P colon R2 plus R1. So here the P is a control variable or control function. Here the P is the control variable or the control function. So this control function, when this control function is enabled, then only this will be performed. Okay, then the control statement is enabled. Enabled means 1. Next, this P is a binary variable. This P is a binary variable. So binary variable means it stores either 0 or 1. 1 means enabled, 0 means disabled. Okay, when it is enabled, it is a control function. So when the control function is activated, then only this operation will be performed. Okay. Now we will see. So this register transfer statement in a diagram. Okay, so diagrammatic representation. Now see here we have a register called as R2. Okay, and here we have a register called as R1. R1 contents are transferred to R2 here. This means that more than one bit. Okay, so more than one bit or more than one line. Okay, are transferred to the R2. So now here we have so here a clock is enabled. Here we have a clock is enabled, and at the same time we have to enable the load operation. Okay, clock is enabled, load enabled. Okay, then the R1 contents are loaded into the R2. But when all this happened, when the P equal to 1. So means when the P is enabled. So means how the P is enabled is, here we have a circuit called as control circuit. Here we have a circuit called as control circuit. So that is generated the P value. If P equal to 1, then load is activated, clock is enabled, and R1 contents are transferred to R2. Okay, P equal to 0 means nothing will be happening. Okay, so we are representing like this. And next one. So sometimes, suppose if we represent this one in a digital clock, clock pulses. Okay, so now this is at time t. Okay, after this is the one clock pulse, and this is at the time t plus 1. Okay, understand? So now this is at the time t. Okay, so this is the t, and so now this is the at time t plus 1. So means, so when the load is enabled, here the clock is enabled at the same time. Okay, so here, okay, this is the data. Okay, this is the data we are transferring, and that is in the low stage. Okay, so when the transfer has occurred at time t, the transfer is occurred. Okay, and at time t plus 1, the transfer is stopped. Okay, the data is transferred at the time t, and it is stopped. Okay, so it is stopped at time t plus 1. Okay, so means for one clock pulse, okay, and the load is enabled and data is also enabled.